Okay, now the last example that we're going to look at is a little more challenging. It's kind of interesting. It's an interesting way to apply this information we've been doing so far. Okay, so this says, let's suppose that we have an arc of length s that lies on a unit circle given by this equation right here. Okay, so what have I got? Let's draw that for a second. Okay, I have a unit circle that looks like this, and because this equation is given by, the equation for the circle is given by x squared plus y squared is equal to 1, I know that the radius of this circle is going to be 1. Now, I don't know if you remember this from some other previous math class or not, but this value right here gives you the square root. In other words, the square root of this value is going to give you the radius of this circle. Okay, so for example, let me back up and say if I had a circle x squared plus y squared is equal to 25, I know it's a circle because the equation is x squared plus y squared, and the radius of this particular circle would be 5. It's centered at the origin, and that's what the radius is. Okay, so the point of all that is I have a circle with a radius of 1, and according to this right here, I know that I have some point P starting here and terminating at the coordinates x, y. Okay? And I want to be able to figure out what these coordinates are for x and y. Given the fact that the arc length, okay, so the arc length here is 2.5. So what are we going to do? Well, the first thing that I'm going to do is I'm going to recognize that both x and y, if I take the cosine, this first value gives me the cosine number. The second one gives me the sine number. And remember, we introduced the lecture saying that if I take the cosine of the arc length, then I get back the x value. And when I take the sine of the arc length, I get back the y value. Because, stay with me here, the arc length and theta are actually the same values. So in other words, it's pretty simple. You just had to remember that part. We know, they're telling it that to us anyway. We know that the cosine of 2.5, okay, the cosine of 2.5, when I do this in my calculator, trust me, gives me 0.8011. And for the y value, when I take the sine of 2.5, I get positive 0.5985. Okay? And sure enough, let's, that would put me over here in the second quadrant, giving me a negative x value and a positive y value. So let's check that concept in one way, okay, by looking at this a little differently, right? We know that the arc length is given in radian measurement. So one more thing we want to just kind of check. Oh, that doesn't look good at all. Let's just check this. Remember that a radian measure, okay, so if this is the length of the radius, excuse me, if this is the radius right there, if I were to measure the radius off around the circle, the perimeter of the circle, so if I made this one radius measurement, so this radius, that length, and this radius are the same. And then, like, picture a string, okay? I took a string, I laid it down, and I moved it this far. And this string happens to be the same length as my radius here. So if I laid that string down on my circle, on the outside of my circle, it would reach to here. Then if I laid this end of the string down at that point and measured, it would be over here. So this would be 2 radiuses. moving along, I lay it down and I get 3 radiuses. 4, 5, 6. There are approximately 6 radiuses in a circle. So having said that, okay, let's come over here and mark this off. So all circles are about the same because their radius is related to the circumference of the circle. Okay, so I have a radius here, I've got a radius there, that's number 2. Here we got 3, 4, 5, 6. That would be 6. So if this is the second radius, right, the length, and this is the third, and we were told at the beginning that I had an arc that had a length of 2.5 radians, then my point xy does fall within that 2.5 area. That's kind of an estimation. Okay, so that's one way to look at this. We can actually estimate based on just this number right here. We can estimate approximately where my point is going to fall along the unit circle based on this idea that a circle has 6 radius measurements moving around the perimeter. Okay, and that's going to conclude this lesson on radians and using that information off of the unit circle.